Here we will learn how to draw a network diagram. If a work breakdown structure is given, we will be representing the activities and the interrelationship between them by drawing a network diagram here. A network diagram looks something like this. You can see that there are arrows and there are few nodes like this, say node 2, node 5. Whether you represent an activity on arrows or on node, based on that we decide whether the network diagram is activity on arrow network diagram or activity on node network diagram. We can have network diagrams like activity on arrow or it can be activity on a node. Here we are going to learn activity on arrow network diagram because this is more intuitive, and we will do some analysis also on this type of network diagram. We take a project for which work breakdown structure is given here. This project has 12 activities. Instead of giving the detail, we are just taking the symbol so that the focus remains on the project management techniques. So the activities we are representing by A, B, C, D, E, F, G, H, I, J, K, L. Time has been estimated, and activity A takes 15 days time, activity B takes 25 days time. The unit of time given here, that is days. So for all these activities the time requirement is given, and the third column that talks about the immediate predecessors. So these columns are representing immediate predecessors. Immediate predecessors for any activity are those activities which are required to be completed before the activity starts. That means that to start A, there is no immediate predecessor, means A can be started in the beginning. Similarly, B can be started in the beginning. But to start C, you need to finish A. Similarly, to start D, you need to finish B. Same way, E can be started only after B is completed. Somewhere like say here, G, you find that there are two immediate predecessors, C and D both. So G can be started only when C and D both are over. If only C is over and D is not over, we cannot start G. And same way, if D is over but C is not over, still we cannot start G. It is necessary that all the immediate predecessors for an activity are completed before the activity starts. So here we have the necessary details. All the 12 activities are given. Their time requirement is also given, and the immediate predecessor relationship is also given. We have to draw now an activity on arrow network diagram which represents this data. Drawing a network diagram will be very easy if we do it in an intuitive way. Here we will be drawing the activity on arrow network diagram, and for this we have to take care that immediate predecessor relationship is not violated. So few important points I am just mentioning here. First, Immediate predecessor relationship should not be violated at any stage. You can draw the network diagram in whatever way you feel like. Look and feel can be different. But if you are maintaining the immediate predecessor relationship, irrespective of look and feel, the network diagram will be correct. Keep only one start node, and similarly you keep only one end node also. There should not be any cycle. It's okay if there is cycle, you can indicate that work breakdown structure is wrong. Cycle means something like this, that if A gets over, B can be started. If B gets over, then C can be started, and if C gets over, then A can be started. If this kind of situation is there, then you will find that the project never gets over. Anyway, this cannot be there in a project. If it appears anywhere, it means that work breakdown structure is wrong. So if we take care of these 3 points, that we don't violate the immediate predecessor relationship and we keep one start node and one end node, then we can very easily draw the network diagram. So to start, look at the activities which are having no immediate predecessor. We make one start node, say this is node number 1 and we call it start. Now from this node we can start only those activities which are not having any immediate predecessor. And if you look at the table, you notice that A and B, these are the 2 activities which are not having immediate predecessor. You cannot start C activity from node 1 or D activity from node 1, because for them it is necessary that some other activity are over. So here, since only A and B can be started from node 1, we draw 2 arrows, one arrow indicating A and another arrow indicates B. You can put A and B in whatever order you feel like. Like if you feel that instead of A here, you will write B and A here, it's okay, that's fine. Now if we take this as say these 2 nodes and we put some number here, 2 and 3. These numbers are again just for identification purpose. You should not have more than one node with same identification. That will cause confusion. So that's why you give numbers 1, 2, 3, 4. You can follow whatever order you feel like, but only take care that more than one node should not be represented by same number. So we have drawn A and B. Now let us see where from C will start. C has immediate predecessor A. A ends at 2. So it is the obvious choice that C will be starting from 2. So we draw a line here and this is the start of C. Similarly, D can be started after B is over, and B is getting over at node 3. So D has to be started from node 3. E and F also starts when B gets over. So that indicates that from end of B we can start activities D, E and F. So we get the idea that from here we should have 3 arrows and we can represent D, E and F by these arrows. This way if we continue we will be able to draw the network diagram covering all the activities and maintaining their interrelationship. We have continued doing like that, and here now you see the complete activity on arrow network diagram, and for easy reference purpose we have given this data of work breakdown structure also. The rules which we learned just a few minutes back, the same rules apply here, and one very good thing is that after drawing the network diagram we can verify and see whether we have maintained the immediate predecessor relationship or not. So let us verify. Now you can look at the network diagram. Say A. A starts from node 1, and at node 1 there is no activity ending. That shows that A doesn't have any immediate predecessor, and that is right here. Similarly, B also starts from this node where there is no arrow ending, so B also doesn't have any immediate predecessor, which is correct. If you look at C, it starts from node 2 where activity A ends. It means C should have A as immediate predecessor. So you can verify this is right. D, E and F, all the three are starting from node 3 where B is ending. So D, E and F, these three activities are having immediate predecessor B. Similarly, if you check for G, G has immediate predecessor C and D, and you see here G starts from node 4, and at node 4 C and D, these two arrows are ending. So you can look here, G has immediate predecessors C and D. Similarly, H also starts from the same node, and for H also immediate predecessors are C and D. You can check I, J, same way. I has immediate predecessor here E, which is correct. J starts from node 6 where F is ending, so J has immediate predecessor F. K starts from node 7 where G is ending, so K has immediate predecessor G, and L starts from node 8 here where H and I are ending, so you can see L has immediate predecessor H and I. So we have maintained the immediate predecessor relationship while drawing the network diagram. Now, few confusions may be there in the beginning, like while drawing the arrows for say C and D, here you are noticing that they have been put in such a way that they end at one node, because in the activity network diagram when we are showing like this, we are taking care that the activities which are starting from these nodes, they are having multiple immediate predecessors, like say G and H are having multiple immediate predecessors C and D. Similarly, here also you are seeing that two arrows are ending, and L has immediate predecessors H and I. For beginners, it may be somewhat confusing, and it is generally seen that people find it somewhat difficult to decide about how they can put more than one activities ending at a particular node. So whenever there are multiple immediate predecessors, beginners find some difficulty, and to take care of those difficulties we can have a concept of dummy activity. Though dummy activity is used in somewhat different situation, but here use of dummy activities can make the task simple, and we can confidently draw network diagram for any type of project. So let us spend some time on understanding how dummy activities can be helpful here. Let's say this situation that for activity G, C and D are immediate predecessor. So suppose you are drawing like this, say C ending here, and D also ending here, and you draw G from here. This is perfectly alright because here you are taking care that G starts from a node where C and D both are ending. But suppose you are not able to visualize this and you have drawn the diagram something like this, say C and say D, and you are not able to conceive this idea that C and D both should be ending at one node, or there are some complications because of which you are not able to get to this. So instead of worrying about how to handle this situation, a simple strategy can be that we use dummy activity, and that is shown something like this. By dotted line, I am just connecting these two ends here, and both these dotted lines are representing dummy activity. So I put dummy 1 and here dummy 2. Dummy activities are no real activity, so they don't take any time. So time required for doing these activities are 0. Now if I put some number like say 1, 2, 3 here on these nodes, then node 3, say we are starting G from node 3. At node 3, 2 activities are ending, both are dummy. This dummy starts from node 1, which indicates end of C. Same way this dummy 2 starts from node 2, which indicates end of D. So at node 3, when dummy 1 and dummy 2, these two are over and they are not taking any time, dummy 1 gets over the moment C gets over, dummy 2 also gets over the moment D is over. So node 3 indicates that dummy 1 and dummy 2 both are over, means C and D both are over, and we can start G from here. So that way we are able to maintain the given immediate predecessor relationship by drawing dummy activities. Here we don't have to bother about the direction of the activities. Wherever we find that for one activity there are multiple immediate predecessors, so from end point of these predecessor activities, we will just draw dummy activities like this, connect them to one node, and from there we can start the activity which has multiple immediate predecessor. Sometimes use of dummy activities becomes necessary. For example, let us take that for activity G, C and D are immediate predecessors, and say for activity K, only D is immediate predecessor. Now if we try to draw like this, say C here and D here, say node 1 and 2, K can be started from here, that is alright, because for K only D is immediate predecessor. But for starting G, if we try to make any node where C and D both are ending, for that purpose, now you can use dummy, something like this, say C and D. So this is dummy 1 and this is dummy 2, and you can see that this particular node, that is node number 3, indicates that C and D both are over, and you can start G from here. So this is correct. Someone can draw even like this, say C, D, and K starts from here. And since you need to have a node where D and C both are ending, so you can just connect them by a dummy activity. Let me change the color of this. So you can connect them by dummy activity, and suppose this is node 1 and 2. Node 2 indicates that D is over, so you start K from there. And node 1, if you look at node 1, there are two arrows ending. One is node 1 is this activity C, and the other one is this dummy arrow, which is indicating a dummy activity. And since this dummy starts from node 2, which is end of D, so at node 1 you can say that C and D both are getting over. So you can start from node 1 the activity G, and this also is correct. If you look at these two network diagrams here, say if this is network diagram A and this is B, you notice that in A there are three nodes, 1, 2 and 3. In B there are only two nodes. Both are maintaining the immediate predecessor relationship. Here you see that G is having immediate predecessor, these two dummies which are saying end of C and D, which is right. Then K has immediate predecessor D, so that is also right. Same way in B also you notice that G starts from node 1, which is end of C, and dummy which is representing end of D. So this immediate predecessor is fine, and for K again there is only one immediate predecessor D. So both are correct, and that indicates that for any given project you can have various types of network diagram. Look and feel wise they can look different, but as long as you maintain the immediate predecessor relationship, they will be correct. This kind of situation where an activity is immediate predecessor of more than one activity in different combinations, it becomes necessary to use dummy activity. Here you are seeing that activity D is immediate predecessor of K alone, and in combination with C it is immediate predecessor of G. So it becomes necessary to use dummy activity here. You can't draw something like this, say C and D, and you make them end at one node, and then from there if you start G, that is alright because you have C and D immediate predecessor. But for if you start K also from here, then you are making D unnecessarily immediate predecessor of K, and that becomes wrong. So in this kind of situation, without dummy activity, you just can't draw the network diagram. So the project which we have taken, where these 12 activities are there, and their time given here, and immediate predecessor relationships given here. This is the activity on arrow network diagram, and the convention is that we write the activity symbols above the arrow and the activity time below the arrow to avoid any confusion. And there has to be only one end node. So if at the end you find that there are more than one nodes open, then you need to connect them to one end. And if immediate predecessors are right, then your network diagram is also right.